Hello students, welcome to my channel. Today I am here to teach you Cbse class 9's first chapter, that is matter in our surroundings. So in the previous class we have studied about some characteristics of the particles of the matter and we have gone through some experiment. In this class we will be studying about the states of matter. So let us begin with it. So what is states of matter? Observe different types of matter around you. What are its different states? We can see that matters around us exist in three different states, that is solid, liquid and gas. These states of matter arise due to variation in the characteristics of the particles of matter. Now let us study about the properties of these three states of matter in detail. So as you have studied in your previous classes, in your lower classes about states of matter, we find things in three states of matter, either in the solid state, liquid state or a gaseous state or gas state. So these all states are just because of the particle or the characteristics of the particle present in the matter. So let us study in detail about the states of matter. The solid state. So activity 1.9. Collect the following articles: a pen, a book, a needle and a piece of a wooden stick. So you have to collect all these materials, that is a pen, a book, a needle and a piece of wooden stick. Sketch the shape of the above articles in your notebook by moving a pencil around that. So take those articles, keep it in your book and move a pen around them and sketch them up. Do all these have a definite shape, distinct boundaries and a fixed volume? So do you think they have a definite shape and distinct boundaries and a fixed volume? Yes or no? You have to tell me. What happens if they are hammered, pulled or dropped? So what happens when you hammer them or pull them or drop them? All these are capable of diffusion in each other. Are these capable of diffusion in each other? So we have studied about diffusion in previous video. So the link is given in the description. So about diffusion. So in the solid, are these particles having the characteristic of diffusion? Try compressing them by applying force. Are you able to compress them? So try compressing them, give some pressure and try to compress them. Are they able to get compressed? All the above are examples of solids. We can observe that all these have a definite shape, distinct boundaries and fixed volume. So all these examples of solid, they have a definite shape, distinct boundaries and a fixed volume. That is, have negligible compressibility. So here you can't compress these solid materials. So they have a definite shape, a distinct boundaries and a fixed volume, and they are negligibly compressible. And solids have a tendency to maintain their shape when subjected to outside force. So if you give some force to the solid also, they are negligibly compressed and they'll maintain their shape. Solid may break under force, but it is difficult to change their shape, so they are rigid. So if you give some force, they break, but they will not change their shape. So they are rigid. Consider the following. What about a rubber band? Can it change its shape on stretching? It is a solid. Is it a solid? So let us take a example of rubber band. Okay, a rubber band is a solid. It changes a shape on stretching. So why it happens so? What about sugar and salt? So even these are solids, but when you dissolve them in water, they get disappeared. What about a sponge? It is a solid, yet we can compress them. why this happens. So in all these three matter, that is about sugar and salt, and about rubber band, and about a sponge. All the above are solids, as a rubber band changes shape under force and regains the same shape when the force is removed. If excessive force is applied, it breaks. Yes, we know this. Whenever a rubber band, okay, if you stretch them, they change their shape, and if you lift them back, they gain back their original shape. But if you overstretch them, they break. The shape of each individual sugar or a salt crystal remains fixed, whether we take it in a hand, put it in a plate, or in a jar. So whatever it is, if you take it in your hand or in the plate or in a jar, a crystal of a salt or a sugar, the shape of which remains the same, which does not change. A sponge has minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it. Why it happens? So sponge has some small holes in them. So when you compress them, the air which is present in the hole will be removed out or expelled out, and you will be able to compress them. So these were the three exceptions of the solid state. The liquid state, activity 1.10. Collect the following: water, cooking oil, milk, juice, and a cold drink. So you have to collect all this. Containers of different shape. Put a 50 ml mark on these containers using a measuring cylinder from the laboratory. What will happen if these liquids are spilled on the floor? Measure 50 ml of any one liquid and transfer it into the different container one by one. Does the volume remain the same? Does the shape of the liquid remain the same? When you pour the liquid from one container into another container, does it flow easily? So when you collect all this, bring different types of container and mark 50 ml on them, and go on changing the container, and once you pour that on the floor and see does the volume remains the same, and change the containers and see will the shape of the liquid remain the same, or will, when you pour the liquid from one container into another, will it flow easily? You have to check these things. Let me answer. We observe that liquids have no fixed shape. So whenever you take a glass of water and pour that in a bowl, so when it is in a glass, it will occupy the shape of the glass. But when you pour that in the bowl, it take up the shape of the bowl. So it does not have a fixed shape but have a fixed volume. So when you are taking 50 ml of water in a glass and pouring that in a bowl, it remains 50 ml. It doesn't change into 40 ml. Yes. So it does not have a fixed shape, but it has a fixed volume. They take up the shape of the container in which they are kept. So in whichever container you pour, if you pour water in the water bottle, it will take up the shape of water bottle, and if you pour in a glass, it will take up the shape of glass. Liquid flow and can change shape. So they are not rigid but can be called fluid. So solids are called as rigid, but liquid can't be called as rigid. They are called as fluid, because whenever you pour this in the container, they take the shape of the container and flow very easily. So these are fluids. Refer to activities 1.4 and 1.5, which you have done in the previous videos, where we saw that solids and liquids can diffuse into liquids. The gas from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are essential for survival of aquatic animals and plants. So as we saw in the activities about diffusion, how solid get diffused in the liquid particles, and also we saw how these atmospheric gases get diffused in the plants and also in the water for aquatic animals. All living creatures need to breathe for survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in the water. So how do you think these fishes and all get oxygen from? So they get oxygen from the dissolved oxygen in the water. Thus, we may conclude that solid, liquid, and gases can diffuse in the liquid. The rate of diffusion of liquid is higher than that of solid. This is due to the fact that liquid state particles move freely, have greater space between each other as compared in the solid state. So, when compared to the solid, the rate of diffusion in the liquids is high because the particles in the liquid can move freely as they have space between each particle. So they have the greater rate of diffusion when compared to the solids. The gaseous state. Have you ever observed a balloon seller filling a large number of balloons from a single cylinder of gas? Enquire from him how many balloons is he able to fill from one cylinder. Ask him which gas does he have in the cylinder. Okay, have you seen this? So he'll have a single cylinder and he'll be filling so many balloons. Take 300 ml syringes and close their nozzles with a rubber cork as shown in the figure 1.4. You have to do it like this. Okay, here you can see in figure 1.4 how these rubber cork is has closed the syringe, the nozzle of the syringe. So next let us see. Remove the pistons from all the syringes, leaving one syringe untouched filled with water in the second and pieces of chalk in the third. Insert the piston back into the syringe. You may apply some Vaseline on the pistons before inserting them into the syringe for their smooth movement. Now try to compress the content by pushing the piston in each syringe. So I'll tell you how. So we have to take 3 syringes. So in one syringe you have to fill them with the gas and in one syringe you have to fill that with the water, and in another syringe you have to fill that with the pieces of chalk, and in the third syringe you don't fill anything, leave it as it is, and you remove the piston and apply some Vaseline and try to compress them and observe that which piston is moving easily and which is moving very hard. So it is obvious that the piston of the gaseous, that is filled with the gas, that is the not either with water nor with the chalk, move very easily because the particles of the gases have more space between them when compared to the liquids and solids. So you can see here in figure 1.5 a solid is kept in a plate. So here you can see the arrangement of the particles, how closely they are arranged, and when coming to the liquid you can see that how the particles are a bit free, and when coming to the gases they are completely free and can move easily. So this was the experiment. We have observed that the gases are highly compressible as compared to solids and liquid. The liquefied petroleum gas cylinder that we get it in a house for cooking or oxygen supplied to hospital in the cylinders is compressed gas. Compressed natural gas is used as a fuel these days in vehicles. Due to its high compressibility, large volume of gas can be compressed into small cylinders and transported easily. We come to know of what is being cooked in the kitchen without even entering there by the smell that reaches our nostrils. How does this happen? Yes, we have studied about this, about the agarbatti. So if something is getting cooked in the corner, so the particles of the gas moves into our nostrils and we get to know what is being cooked in the kitchen. The smell, yes. So this so the pressure exerted by the gas is because of their force exerted by the gas particles per unit area on the walls of the container. So the diffusion rate will also be high in the gases when compared to the liquids and solids. So this was about the solid state, the liquid state and the gaseous state. So we have gone through the experiment. So only thing you have to keep in your mind is the arrangement of the particle, the compressibility. So and you have to keep in mind solids are rigid and liquids are fluids. Gases the particles of the gases are randomly moving as they have more space between them. So the particles of the solids will be very tightly packed, and the particles of the liquids will be a bit loosely packed, and they'll have some space between them. So this was about today's video. In my next video I'll be solving some exercise questions. So please stay connected with me, and thank you for watching this video.